Okay, you've seen the headlines. You've definitely seen the demos. AI can code. AI is coming for developer jobs. But does all that hype actually match up with what a professional software engineer does day to day? We're going to break down the difference between the slick demo and the messy truth.
And look, let's be totally fair. The things these models can do are pretty incredible. Modern LLMs can spit out working code from just a sentence or two. They can absolutely crush the kinds of algorithm puzzles you'd get in a big tech interview. The progress here has been nothing short of explosive.
But here's the billion-dollar question, right? Is that what a software developer really does all day? Just solve these little self-contained puzzles? Or is the job something way, way messier? That's exactly what a team of researchers from Princeton and the University of Chicago wanted to find out.
So to really get to the bottom of this, we have to first look at how AIs are usually tested. And it turns out most of these benchmarks are basically the coding version of an open book test, where all the answers are on page 1.
Think about it like this. On one side, you have your standard AI test. It's a clean, isolated problem, like, hey, write a function that sorts a list. Simple. But on the other side, you have the actual reality of a developer's job, trying to find a bug by digging through thousands of interconnected files, where the entire problem might just be a single misplaced comma. It's a totally different ballgame.
The authors of the study really just hit the nail on the head with this. The real skill isn't always writing brand new code. A lot of the time, it's about understanding, editing, and fixing code that's already part of a huge, complicated system. Okay, so if the old tests were way too easy, these researchers realized they needed to build a new one. They needed to create a true coding gauntlet that actually feels like the daily grind of a software engineer. And they called it Swe-Bench. Now, instead of some made-up academic problems, they went straight to the source. They pulled over 2,000 real bug reports and feature requests from huge, popular open-source projects. We're talking about giants like scikit-learn, Django, and Matplotlib. The AI's job was simple. Here's the bug report, here's the entire codebase, now go fix it.
And they were seriously rigorous about building this thing. They started with, get this, 90,000 pull requests from Github. Then they filtered them down, making sure every single problem was tied to a real issue. And here's the critical part. They made sure that the human solution had tests that failed before the fix and passed after. This proves that every one of these problems is a legit, verifiable challenge. No faking it.
So, the stage is set. They built the ultimate real-world coding test. They lined up the most powerful AI models on the planet, and then they pressed go.
All right, this is the moment of truth. We've got the benchmark. We have the AI champions, models from OpenAI, Anthropic, all the big names. So, how'd they do?
The results were, not great. In fact, they were pretty shocking. The absolute best model they tested, Claude 2, could only successfully solve less than 2% of the problems. Let that sink in. On 98% of real-world coding tasks, it completely failed.
And this wasn't just a bad day for one model. As you can see, every single one of them struggled. The specialized models, ChatGPT, even GPT-4 on the problems it was tested on got a big fat 0. The takeaway here is crystal clear. When you put today's AI up against the real complexity of software engineering, they just can't hang. But, this isn't just about dunking on AI. The real gold here is in understanding why they failed so badly. What parts of a developer's job are just too tough for these models right now? The single biggest problem, by a long shot, was context. These codebases are just enormous. They're these massive digital haystacks. And the AI's job was to find the one or two tiny little needles, the lines of code that needed to be changed, and it just got completely overwhelmed by all the noise. In fact, the data shows a really clear trend. The more code you have to stuff into the AI's context window, the worse it does. It's the difference between asking it to find a typo on a single page versus telling it to find a typo somewhere in an entire encyclopedia. The models just lose focus. And what's really telling is that even in those rare cases where the AIs did succeed, it was only on the easiest problems. Your average human fix involved changes to multiple files and functions. But the AI successes, they were almost always just a small tweak to a single function in a single file. They were just picking off the lowest hanging fruit.
The researchers also dug into how the AIs failed, and they found some other big problems. The models would often write this really clunky, primitive code, totally ignoring useful functions that were already sitting right there in the library.
They also had this very greedy approach. They'd fix the immediate bug, but in a way that might break something else or just violate the project's coding style. And sometimes they just failed at the simple task of formatting the code correctly.
So does this mean AI coders are a dead end? Is it all just hype? No, not at all. In fact, this massive failure is probably the best thing that could have happened for the field.
And that's exactly how the researchers see it too. This isn't about saying AI is bad. It's about finally having a yardstick that measures what actually matters so that we can start building models that are genuinely, practically useful to developers. So when you get right down to it, SWE-Bench isn't a dead end. It's a roadmap. It tells us exactly what AI needs to get better at. It has to get way, way better at navigating huge code bases, at understanding how different parts of the code interact, and at thinking about the consequences of a change, not just the quick fix. And that kind of leaves us with a final thought to chew on. Maybe the goal here isn't about replacing developers at all. Maybe it's about partnership. I mean, what if a future AI could solve just 5 or 10% of these real-world bugs? That could free up human developers to focus on the truly hard, creative problems. And that sounds like a future worth building.